Computer Science A, Unit 7, Array List, Lesson 4, Linear and Binary Search. The objectives here are to review the steps in the linear search algorithm for arrays and use with array list, and to understand the binary search algorithm for arrays and array list. First off, a linear search can apply to any set of values. Example, an array, array list, or even a string, as it is made up of individual characters. It works in a rather straightforward way. You start at the beginning of a data set. Is this the value we're looking for? If yes, stop searching. If no, move on to the next item. Repeat step 2 until we found what we're looking for, or until we reach the end of the set. A linear search in an array would be something like this: public static int, search linear int num int list. Notice that you're passing in, let me get my better pointer, if you will. Okay, so you're going to return an int. That's what's returned. You're going to pass what you want to find. So num is what I want to find in this thing called list. So we start at the beginning of list. We go all the way to the end. Remember, it's less than, not less than or equal to, I++. If num, if the guy I'm looking for is equal to, remember the double equals for comparison, the item that is in list sub I, I'm going to return I. So this is the index where found. So if I find it, not only am I going to let you know that I found it, but I'm going to tell you where it is in the list. Now, if you go through this entire list and you do not find it, this indicates not found. And it's -1 because we can't have an index of -1 into our list. Now, what if we're doing an array list instead of an array? Well, notice it looks very much the same. Public static int search linear, public static int search linear. So far, we haven't changed anything. Int num, int num. Ah, here is my first thing that's different. Instead of int list, instead of an array that is a list, I'm going to pass it an array list of integers. Now remember that integers are objects, not primitives. Okay? So then, and down here, my return -1, that too is if it's not found. Now, how do I loop through it? It's very similar. For int I is set to 0, I is less than list.size. Notice it's not .length, it's .size, and it's a method because this is an array list, which is an object, but this is still telling me to go through my entire list. If num equals list.getI, oh, how can I do this when what is contained in my list is an integer? Remember the auto unboxing? When I want to do this comparison, list.getI, I'm going to get the value, and then it's going to unbox it as an int. So this is where I don't have to worry about it. I can treat it. The auto unboxing is going to allow me to treat it as if it's an int, even though it's an integer. Okay? Now, the linear search is the easiest searching algorithm to understand. It's very straightforward. You get a pile of papers. You start at the beginning. Look through them. However, it can be very slow for large data sets. And whatever you're looking for is not at the beginning of the data set. Therefore, we have another searching algorithm that we call the binary search that will be much faster, especially for large data sets. The binary search algorithm is known as a divide and conquer algorithm. You are still searching for a value, like in the linear search, but you split the array, so you do not have to always look at the whole array to find the value you're looking for. The only thing that must be true about the array is that before you try the binary search, the list or array list is sorted. And you know whether it's sorted in ascending or descending order. Another difference is that we will be using a while loop to iterate through this process, not a for loop. because we are not necessarily going to look at each element until we exit the loop. Okay? So while loop, and it must be sorted. Now the pseudocode for this is assign the low index to 0, the high index to the highest index. While the lowest index is less than or equal to the highest index, find the middle index. If you find the value of the number or whatever you're looking for at the middle index, return that index. Otherwise, to check to see if the value is higher than the middle or lower. If it is, you look through the higher part of the array by making your low index equal to the middle index. Otherwise, look through the lower half by switching the high index to the midpoint. Now all of this, mid, high, low, middle, gets confusing when you read the words. So before we look at the code, let's trace through an example. Okay, here's an array, and we're going to go through the binary search algorithm to find the number 10. Now notice, in blue, those are the index values. In black, those are the values in the array. Now what you need to notice is that the values in the array are sorted. 2, 3, 6, 10, 13, 19, 20, 23, 25. So we start out with the array. And the very first thing we do is we set the low equal to my lowest index 0. High is 8. How do we find the middle? Low plus high, okay, divided by 2. That's how we find our middle, and it's integer arithmetic, so it's going to just truncate it. So we look at 0 plus 8 divided by 2 is 4. Okay. Divided by 2 equals 4. What is at location 4? 13. Well, 13 does not equal 10, and I'm looking for 10. Since 13 is more than 10, I'm going to skip looking at this upper side of the list or the array list because it can't be there. It's less than 13, so I'm going to look at the smaller side. So now that means that where 13 is going to be the highest. So my high value takes on the value of the middle. My low stays the same. Now, 0 plus 4, I take that quantity and divide it by 2, and I get 2. What's in location 2? The value 6. Does 6 equal 10? No. But now 6 is less than 10. So what I'm going to do now is eliminate the bottom half. And now I'm just going to look at the top half. So now the low value takes on 2. The high value stays the same. Now I've got to find the middle. So 2 plus 4 is equal to 6. Divided by 2 is equal to 3. Now I'm going to check the value here at location 3. Notice I'm not changing my list. I'm just not going to look at this part. Now I'm going to look at location 3. Is it 10? Yes. And since it's 10, I'm done, and I'm going to return the value 3. Now, if I didn't find it there, I would go high or low, and essentially it would end, and I would wind up with a -1. Okay? So, looking at the example we just walked through, let's answer the following questions. And before I reveal the answers, pause the video and you answer these. Okay, so how many iterations did it take to find the number 10 with the binary search? Well, we had to look at 13, at 6, and then at 10. So it took 3. How many iterations would it take this with a linear search? The linear search, I would have gone 1, 2, 3. I would have found it on the 4th. So notice, it would have taken more. Okay? Now, for the following questions, determine which situation would be better for a linear search or binary search. If you have an ordered list of numbers, binary search. The only time the binary search really isn't better is if your item is in the first part of the list. An unordered list of numbers, you're going to have to do linear. No matter what the size, you're going to have to do linear. Now, what about an ordered list of numbers where the number you were looking for was the first element? In this case, a linear search is better because you're going to find it first comparison. But if it's not the first, you're going to go to the middle and then either side. An ordered list of numbers where the number you're looking for was the middle element, definitely binary. An ordered list of numbers where the number you were looking for was the last element, again, definitely binary. You have a very large data set, and other than being in the first spot or two, binary is your preference. Okay? So typically, binary is best as long as you can get it ordered. Now, code for a binary search for an array in an array. Remember, this is an array. An array list is going to be very similar with a few modifications, similar to what we did for our linear search. On the AP exam, most questions involving the binary search will only involve arrays. Okay, so we've got public static int binary search. So far, looking the same except the word binary replaces linear, and you have an array and an int num. Right here, just so you know, these two, doesn't matter the order that you write it in, but then when you call it, the order matters and what you pass it. Okay? So when you first start out, your low is always 0, and your high is always the length minus 1. Here, if this was an array list, it would just be array.size, which is a method, minus 1. Okay? So that would be your change. Then while low is less than or equal to high, you're going to find the middle. And remember that this does integer arithmetic. Okay? So if num is greater than array middle, low becomes the middle. Else if num is less than array middle, high becomes middle, else return middle. And if you get all the way through this loop, this right here says it's not found. Now, changes, obviously you would have to change array dot get whatever value, in order to access an array list. The other thing, if you were searching for strings or for characters or for some other object, you would have to use the dot equal method, okay? And then it would have to have some way of being ordered. But essentially it's the same thing, and for the most part, when you're doing this on the AP exam, they're going to be working with numbers, okay? This is making sure that you understand how a binary search works, how a divide and conquer search works. That concludes lesson 4. Remember, linear search and binary search, you're looking for something in an array or an array list. For the most part, you'll be working with arrays on the AP exam. Linear search is the easiest and most straightforward. However, the binary search is almost always faster, with the caveat, it must have sorted data. Okay, that's it.